which is assignment number 5, which is also based on the graph. And in this assignment, we will be using now the adjacency matrix representation for the graph. Okay, so I'll first the area around the college as a graph. Okay, so you have to imagine the prominent places around our college as vertices and the road connecting those places as the edge. Identify the prominent landmarks as nodes and find minimum distance to various landmarks from the college as the source. Represent this graph using adjacency matrix. Okay, so we will be identifying some few landmarks, 7 8 landmarks, and we will try to draw the graph for such premises. Then find the shortest path using Dijkstra's algorithm. Okay, so this should be a weighted graph, and we will use shortest path algorithm from college. We want to find, so college will be the source node, and from that particular source you have to find out the shortest path to remaining all vertices. Okay, that is remaining landmarks using Dijkstra's algorithm. Okay, this is the application given which we have to solve using Dijkstra's algorithm. So before moving ahead, we'll open the algorithm. Okay, this is the algorithm which we saw, where first we will initialize all the arrays, distance from array, okay, and visited array. The distance of S is initially 0, its own distance is 0 for all vertices V minus S, that is except source vertex. For all the other vertices, we will imagine initially distance as infinite. And then S is set of visited vertices which is initially empty, and Q is the uh, uh, set which contains all the vertices. So one by one we will visit the vertex and we will delete that particular node from this Q set. Okay, so this is the algorithm given. For this we can use other structures, like we can use array for uh, storing the flag whether it is that particular vertex is visited or not. Okay, so after all this initialization, this while loop is our actual Dijkstra's algorithm. While Q is not empty, that means we visit all the vertices till that time. Do U is equal to minimum distance. We will find the minimum distance from the distance array, and then we will add that U to the list of visited. Okay, we will mark that node as visited, and then we will check the neighbors of it, whether two non-visited neighbors. Okay, we can have better distance path from this vertex U which we have selected. Okay, from vertex U, whether we are having the better path to all the remaining non-visited vertices. If it is there, then we will replace that particular path with new distances. Okay, so this is the algorithm, and we also have seen the example of this algorithm, in which we did the same thing. First step is to create cost matrix, and from that cost matrix we will take the row of source in our distance array, and visited array is there. For every vertex there will be a flag for visited or not, and from array is there. So initially source vertex is the predecessor for all. Okay, in the step 1, as we are starting with vertex 1 here, we have copied the uh, cost matrix, that particular row of source vertex, row of 1, into distance array. Then visited we have marked 1 for vertex 1, and from array is vertex 1 everywhere. This is the step 1 of our algorithm. Okay, we'll see the particular code. Okay, initialization code, how you will initialize the graph. First you have to create the adjacency matrix. Okay, that adjacency matrix is nothing but your graph. So here in this case this is the graph G with max, where max is 20. So maximum we can have 20 vertices in our graph. Okay, and this is the memory allocation for that G, and n is actual number of vertices in our graph. So in constructor initially n is 0. Okay, and we have read graph and print graph functions. In the read graph we will completely initialize this adjacency matrix with proper weights, and print graph we will display the non-zero edges. Okay, and then after our graph is created properly, we will go for the Dijkstra's algorithm for finding shortest path from this start vertex, which we have taken from user. Okay. So before going to functions, in main function we are calling the read graph function, then print graph function, and then if it is graph is created properly, we will take the start vertex from user and then find out the shortest path to all vertices from that start vertex. Okay. So see here, read graph function. Here we are taking first the number of vertices from user, and we are initializing all the values n by n matrix. In that n by n matrix, we are initializing all the values to 0 first. Okay, and then we are taking number of edges from the user, and for every edge we are taking source, destination, and weight, and that particular edge is written at g of vi to vj, that is source to destination, and vj to vi, that is destination to source. Okay, as we are not uh, saying that our graph is directed. Okay, this is for undirected graph. It is, if it is directed, then we will be adding only one edge for every particular edge. It will be reflected at only that particular row. But here, as we are not saying that it is the weight, it is weighted graph, but it is not directed graph. Okay, that's why it is symmetric matrix, which we will have. Okay, so vi to vj and vj to vi is equal to weight. Clear? So our adjacency matrix will get created from this read graph function, where initially we have initialized every value to 0 in the matrix, and according to the number of edges which are existing, we are taking source, weight, and destination for every edge, and that we are adding in our, that weight we are writing at the source to destination, that in the row of source and the column of destination. Okay, we are writing that particular weight twice. Is it clear? Read graph function is clear. How to create adjacency matrix? Yes. Okay, this is simpler than adjacency list, isn't it? We have to just create a matrix for it. Yeah. Then we can move ahead. In print graph, we are displaying details of non-zero edges, and that too for even if we display for only upper triangular or lower triangular matrix, it is fine, because all the edges get repeated in the other part of the matrix. Okay, so we will display every non-zero edge only once. Okay, that means if 2 3 is displayed, I will not again display 3 2. Okay, so list of edges in the spanning tree are I equal to 0 to n minus 1 and j equal to I plus 1 to n. Okay, so here we are following the upper triangular matrix conditions. And if the age, that particular g of ij value, if it is not 0, then only we are displaying its details, source, source, destination, and the weight. Okay, that we are displaying. Clear? So here we are only displaying the list of edges which are non-zero, and that too we are displaying only once. Then, after the matrix gets created, we have to find the shortest path from source. The source we have taken in main function and that we are passing to this Dijkstra's function. Okay. And now here we have to first initialize all our variables in this function. For shortest path, we will initialize the cost matrix, which is having same dimension as adjacency matrix. Then we have the variable minimum distance, which will store current minimum distance. Then distance array from array and visited array. All these three arrays we all are aware of. We have used it in prims as well as Dijkstra's algorithm, isn't it? So same variable we are using here. Any doubt in the declaration? And this next node, it is the node which is to be visited next in the next step, next iteration. Okay, for that we are taking this particular variable. Then after declaration of all these variables which are required afterwards, we will first create the cost matrix, where every zero value in the adjacency matrix will be replaced by infinity. This infinity is declared here, hash define infinity to 9999, some greater value. Okay, and our first step in this algorithm is creating the cost matrix from adjacency matrix. So for I equal to 0 to n and j equal to 0 to n, if j of ij is 0, then we are replacing that 0 with infinity. Cost of ij is equal to infinity. Okay, so this cost matrix is created from adjacency matrix. This g of ij, g is our adjacency matrix. Okay, and from that we are retrieving 0 values, we are replacing it with infinity. And all the non-zero values, they will remain as it is. Okay, so our cost matrix will get created from this. Okay, then second step is after cost matrix creation, we are declaring initializing all these three arrays. Distance of I is cost of start I. That means we are accessing the start vertex, the source vertex row. Okay, and that complete row we are copying. That's why all the elements of that particular row will be copied into distance array. I'll keep the example in front of us so that you can relate it. So this is our initialization. So we are copying all the elements from this cost matrix, the source vertex, which is 1. From that, we are copying all the elements, n elements in this distance array. Okay. So distance array gets initialized with this. Then from of I is start. For every vertex, from array is having 1. Okay, that is start vertex. Whichever is start vertex, from that we have taken all these distances. So everywhere predecessor will be that start vertex. Then visited of I is 0. Here initially visited of I, that is for all the vertices visited is 0, and we will only make visited for start vertex as 1. So we will only replace visited of start to 1 because we have copied all the distances from that start vertex. Okay, so it will be marked as 1, and distance of start is replaced with 0 because it is not infinity. Self distance is 0, so this distance will also get modified to 0. It will also get visited, and count is 1. That means we have visited one vertex, which is start vertex. Okay, is this much clear? Is the initialization clear? If initialization is clear, then only we can start with actual Dijkstra's algorithm, the processing of all these arrays. Shall we start the processing of all these arrays? Yes or no? Fine. So now, after your initialization of all these arrays, etc., is done, then We will now find minimum distance from the distance array. That is our first step in the. So this while loop is nothing but our actual Dijkstra's algorithm. This while count is less than or equal to n minus 1, because we have to visit each and every vertex. That's why. So until count is n minus 1, minimum distance is equal to, initially we have assumed that it is infinity, and now we will start accessing the distance array. In the distance array, if we get better distance age and if that particular vertex, ith vertex, is not visited, okay, so for all non-visited vertices, whichever is better distance age, that will be the next node which will be visited. So next node is equal to I, and minimum distance is distance of I. So we start with vertex number 0, then 1 till n minus 1, and if we see that that vertex is not visited and we are getting better distance age, okay, that is distance of I is less than minimum distance, so we are finding from that complete array whichever is the least cost age, that will be there in the distance, that minimum distance, okay, that will be the minimum distance, and that vertex is next node. Okay, so here in our case, minimum distance is 12, and next node is this V, which is 2, vertex number 2. As from this, we can find that 12 is the minimum distance from non visited vertices. This is the age with minimum distance, so that will be the next which will get visited. Okay, so this will be the next node 2, and in minimum distance, we will have 12, the actual distance. Is it clear? So this is the first step of Dijkstra's algorithm to find minimum distance age from non-visited vertices, and then mark that next node as visited. So visited of next node is 1, and then we have to check whether we are getting better distance path from this next node if we keep this next node in between. Okay, if we take this in between, then whether we are having any better path to the vertices, other vertices which are not yet visited. Okay, so in this from array, we are updating the distance array based on the whether we are getting better path or not. Okay, so for I equal to 0 to n, what we are doing, we are checking if the particular vertex is not visited. For non-visited vertices only we have to do this. Okay, if minimum distance, that means distance required to come to that particular vertex next node. Okay, so that distance will be taken into consideration, plus cost of next node I. That means from this next node, if we are getting better distance than current distance, current is distance of I, and if we keep this next node in between, whether we are getting better distance path or not. Okay, that we are checking. Is it clear? This minimum distance is distance required to come to that particular vertex which we have selected, and from that vertex we will check whether for the remaining vertices, if we are getting better path, this is the better path if next node is in between. Okay, and this is the current path, distance of I, the distance which is there in the distance array to that vertex I. So if we are getting better distance path, then we will replace it. So distance of I will be replaced with this better distance, this distance which is lesser. Okay, it will be replaced, and the predecessor also will get modified to next node because we have found better path from this particular vertex next node. Okay, which we have visited recently. Is it clear the effect of visiting? So after marking that particular node as visited, we are checking what is its effect on other paths, remaining vertices, which we have not yet visited. Okay, so this is for uh, checking the effect of that particular vertex which we have visited. And then count plus plus because we have visited one vertex. Okay, and then again the next minimum distance will be calculated. Then again that vertex will be marked as visited, and we are checking whether it is giving us better path to non-visited vertices or not. Is it clear? That's it. This is the Dijkstra's algorithm. And now we have to show the output after the processing. Okay, after this while loop is over, that means this is the actual algorithm, Dijkstra's algorithm, which is working. This while loop. Okay, this while loop is only our Dijkstra's algorithm. And now we have to display the output in the proper format. So those from array, distance array, and visited array, the final ones which will be created in this loop, they are the actual output which we will be representing in the better format. So as we have discussed here, this will be the finally processed output. For distance array, visited will be one for all, and uh, this will be the from array which will be helping us to get the path. Okay, after we get such arrays, we have to interpret these arrays. So this is nothing but the distance from source to this vertex number 0. This will be the minimum distance from vertex number 1 to vertex number 2. Okay, this is 1 to 3, this is 1 to 4, this is 1 to 5. Okay, so same we will display here. Okay, so for I equal to 0 to n, okay, we are displaying the distance of I. Okay, and for every vertex now, so distance in that is the minimum distance, and for displaying path we need a loop until I is not start. Before going to the code, we will just see how to interpret this path from here from array. So if I want to find the path from this vertex number 5 to source vertex 1, okay, the distance I know that it is 26, and the path will be 5 to 3. Then we'll go to vertex number 3, which is this one, then 3 to 2, and vertex number 2, 2 to 1. Okay, so until I reach to source vertex from this destination, I will go back. Okay, 5 to 3, 3 to 2, and 2 to 1. So finally I reached the destination vertex, which is 1. Sorry, this is the destination from where we started, this 5, and we reached to the source, which is 1. 5 to 1, we have obtained the path, which is 5 to 3, 3 to 2, and 2 to 1. Is it? So we are tracing the path like this here. If I is not equal to start, that means until we get the start vertex, what we have to do? We have to display the path like first I will be displayed, that is destination vertex. Then j equal to I, and do j is equal to from of j. So this loop will take us to from of j until j is not equal to start. So for every ith vertex, this will be done. The path will be traced till source. Okay, we start from that current vertex and we reach to the source vertex, which is start. So until j is not equal to start, we are accessing from of j. Display that. That is the intermediate vertex. Then again, j will be equal to from of j, that will be displayed. So all the intermediate vertices will be displayed and complete path will be obtained. Is it clear? Is the algorithm clear? This loop is only for displaying the output in the proper format. And actual Dijkstra's algorithm is this one only, this while loop. Before that, whatever we have, that is initialization. Okay, this while loop, the 2-3 steps which we have followed here. This is actual Dijkstra's algorithm, where we first find the minimum distance h, then we visit that particular vertex, and we check the distances to remaining vertices from that. If we are getting better, we will replace it. Okay, and this is only for displaying the output in the required format or interpreting the output arrays. Okay, any doubt here? Do you have any doubt? We'll try to execute this program. Is the algorithm clear? So you can mock up this program and you can execute. But to show whether your program is working correctly or not, you have to solve an example like this. Okay, which will tell whether your created these arrays they are correct or not, and whether you are getting the correct path or not. So for that you need to solve an example like this. Okay, which we have done in the class. I'll execute the program. I'll input the same graph which we have solved and check whether we are getting the correct output or not. The number of vertices 6, number of edges 8. Enter every edge. For every edge you have to enter source, destination and weight. So I will enter 0, 1, 15, then 1, 2, 12. Then we have 2, 3, 10, then 2, 5, 15. Then we have 3, 5, 4. Okay. Then we have 3 to 4, which is 9, and 4 to 5, which is 8. One edge is remaining. Which one is this? 3, 4, 5, 6, 7. Which edge is remaining? Yes, A to D, that is 0 to 3, which is 10. Okay, so this is our complete graph which is displayed, and we have to take the, it should not be a spanning tree actually, it should be a graph. Enter the start vertex. Start vertex here we have solved by taking 1 as start vertex. So this might be our college, and these are the prominent places around it with the weights and the connections. Okay, check whether we are getting the same or not. So distance of 0 is 15, then 1 is not displayed because it is self distance, so it is not displayed. Distance of 2 is 12, 3 is 22, 4 is 31, 5 is 26. So correct, yes, we have obtained it. Then path, see the path 0 to 1, then 1 to 2, then 3 to 2 to 1, 4 to 3 to 2 to 1, and 5 to 3 to 2 to 1. Okay, so we have obtained the path also properly. Any doubt here? You can display all the versions of these arrays, distance from and visited array in that while loop. Okay, so that you will check whether your all versions which you have solved here on paper are correct or not. Okay, so both should match, your program as well as your example which you have solved, all should match. Any doubt, any explanation required further? And if you complete this Dijkstra's algorithm, then it will be similar to In prims we have to follow the similar strategy, but only some part will be different. We don't have to update the paths because of that, okay, which we are doing here.